Hi, good afternoon. Welcome back to Mike Makes It. Been online and I've ordered some printed circuit boards from JLCPCB. Not sponsored by them, but I'm finding them very reliable. The price is really good. The turnaround is phenomenal. In this box, I'm doing a little bit of work for a client. In this box, the work in here is for myself for the Land Rover. But we'll open this one up in a second. Basically, I paid for DHL to have this shipped to me, so I had it. The turnaround was very quick. 2 days shipping time from China. This took about 10 days. I ordered this literally 10 days before this, and they turned up on the same day. And it was only about 10 or more, so all in all, maybe DHL's a way to go if you're in a hurry. Royal Mail is fine, but add 10 days or a week or so to the production time from the time JLC PCB have made it to the time you get it in your house, certainly in the UK. But we'll have a very quick look at this. The video isn't about these printed circuit boards, but what I was interested in, JLC PCB, they offer a surface mount option. So basically, not only do you give them the Gerber file for the printed circuit board, but you also give them a BOM, a builder materials list as well, and they'll actually solder them onto the boards for you, which can be very useful, particularly if you're using the very small surface mount components like we are there. So yeah, that's how they come. They a bit of tape on the back. Some of the components are hand soldered. If you look on the other one, other PCB I'm going to show you in a second, some of those components were hand soldered, and they do pay a little bit of extra charge for that, as do you if you use what they claim are extended components. Their extended components being not quite so run-of-the-mill resistors, capacitors, relays, etc. I think they got a nearly 700 basic components, so there's no handling charge for that. With extended components, it's still only pennies, but there's still an extra cost for every extended component you use. It's all on the website. I'll put links in the description as normal, so you'll be able to follow it up. But we'll have a look at this. This is what the video is about. You get a jigsaw, in this case with it. I had a cat mobile phone holder last time, so things are looking up. So we'll put the jigsaw to one side, get our box out of the way. Very well packed in a box, so far I've not had any damage to any of the boards that I've ordered so far. Now, let's just get the packaging out of the way. The camera's going to go a bit wobbly because I'm going to just zoom in there. There we go. Right, now you might have seen an earlier video, all to do with my truck again, and when I changed the battery in the truck, I did a quiescent current test, and it claims with everything switched off, ignition keys out, door closed, interior light switched off, the lot, it was drawing 65 milliamps from the battery. Now that's too much in my thoughts. We should be about 25. So when I disconnected my deployable step project, which is also online, you'll be able to see that if you wish, the actual step itself in quiet mode, quiescent mode, draws, well, it actually was drawing 65 milliamps. I tell a lie there. The total quiescent current draw of the truck when it's everything shut down is 135 milliamps in total. Now I'm looking for about 25, and that's a standard Land Rover will draw 25 milliamps with everything switched off. So 135, way too much, and that's going to knock your battery out. That's going to definitely shorten the life of your lead acid battery over the period of years. So what this little thing is here, there's 5, that's kind of how you got to buy them. You buy 2 populated and 3 blanks, or 5 fully populated. So for the additional cost I went for 5. If anybody else is doing a step project and they can show me online and you think this is any good and you want one, let me know. There's 2 up for grabs, but you got to show me the step project so I know you're going to be able to use it, or come up with another good reason to use this. But there you go. Hopefully that's in focus. These are the sort of components they will hand solder. They can't they can't solder them on the machines. Likewise with this component, I believe that was too big. Might be mistaken, but certainly the relay and the connector, That's all hand soldered, so there's a small charge to actually put them on the board and solder them in. But yeah, you produce a Gerber file with easy EDA. There's a lot of help online for that, so there's no need for me to do a video to help you with that. But dead easy. You build your schematic diagram, transport it over to PCB creation like this, move the components where you want them, and away you go. And so basically what this will do, when I open the passenger door or the driver's door, this board will fire up. In turn will fire the deployable step up. Step will open, step will close as normal. Close the door, and there's a small time delay built into here before it drops the power off to the step. And that's going to save me at least 65 milliamps on the quiescent current draw. So yeah, cut a long story short, this is an additional battery saver to drop out my deployable steps. So what I'll do, I'll wire this up on the bench, and it'll give you a little bit more of an idea of what I'm trying to create. And then we'll go over to the truck and install it and just see if I've got the schematic right. Okay, this is a battery saver board for my deployable step in the Land Rover. Effectively, when the step is in standby mode, it draws over 65 milliamps from the car battery, and in my book that's not desirable. So basically what this does is interrupt the power supply to the step. So when the doors are closed, this actual circuit here, that will draw half a milliamp, and that's a good substitute for the 65 milliamp draw from the step in standby mode. Now, one of these cables, one's ground, the other one is effectively going to be connected to the interior light switch. So in the UK, typically, when you the interior light, one side is powered 12 volts all the time, the other side is looking for a negative supply, and when it sees a negative supply, the interior light will come on. So I'm using that principle for when this wire I'm waving around here is shown an earth or negative, this module will power up. It's got a pair of normally open and normally closed contacts. We're looking for the normally open ones. So when this module powers up, the normally open will go to normally closed and stick 12 volts up my deployable steps. Deployable steps will open, I'll climb in the Land Rover, I'll close the door. After a small period of time, the steps will close well within the time delay built into this board. Steps will close. After, I think it's about 10 seconds I've set it for. 10 seconds it'll drop the power off the step. But should I want to get out the car again, I'll open the door, this will power up, steps will drop. So basically, here we go. Well, I'm going to touch these together, that's simulating the door opening, and I've got a continuity buzzer over that way where I'm pointing, and you'll hear a bleeping noise. That's just to simulate the relay closing. So here we go. Blue light on here, that's the door switch being open, and this is basically powered to the circuit saying it's powering up the step. If I close the door, blue light goes off, time delay is coming into force now, capacitor's discharging, and in a few seconds the relay will trip out, simulated by the continuity buzzer. So that's what I want, that's what I've got. So the next step is put this into the truck. So yeah, over to the truck, here we go. Right, before I fit the module, I just want to show you the current this module for the step draws on this meter when it's powered up. So I've pulled the fuse out, got a meter that's going in series with it. There we go. Now this is blipping away because it's drawn over 400 milliamps. That's mainly because the steps are deployed and under there we got a light going on. So they draw an amp a piece. So we're drawing about 2 amps when it's in action, so to speak. So that's fine, I ain't got a problem with that. Let's effectively pretend we're closing the steps. So I close the door. Steps close up. Couple of lights still on the control box as normal. And we've drawn 51 milliamps. Last time I measured it, I tend to remember it was 65, but we got 51 on there. Now remember, that's 51 milliamps all the time the doors are closed, whether the truck's running, whether it's sitting on the drive for 2-3 days. So what I'm going to do is put that module in line with the fuse, hook a couple other cables in which I need to for power to the module and also to the door control, or in fact the door switch, and we'll see if we can bring that 51 milliamps down to less than half a milliamp in quiescent mode, quiet mode, parasitic mode, whatever you want to call it. But basically doors are going to be closed, this step module will go to standby, and we're going to be drawing less than half a milliamp, which is considerably less than this. So I'll just hook that in now, and we'll show you the difference. Right, it's only a bit of a lash up at the minute. It's just sort of proof of concept. No reason why it shouldn't work, so we'll give it a little try now. What I've done this time is connected the multimeter measuring current in series with the module itself. Basically, when the module activates, the relay will go open circuit, taking all the power whatsoever from the control circuitry. So I have measured it. That is absolutely no current at all being drawn when the doors are closed. So basically, we'll open the door and make sure everything works okay. So here we go, door opening. Hold on, cables fell out there. I'll say a little bit of a lash up at the minute, but I think we should be good. Right, door opening. Now that meter's overloading currently because we're drawing about 60 milliamps to the control circuit, that circuit there. However, when we close the door, you see there's a couple of lights on there. The light, there we go, you've got a green and a blue. When we close the door, the step will close. Okay, and it's tripped the relay, well, not quite tripped the relay out yet. It's still got power on the step control circuitry. There you go, killed it now. So we've lost all power whatsoever to the step control circuitry because we don't need it now because the doors are closed, the step's up, and the quiescent current draw will drop down to about half a milliamp for the control circuitry. This little board here, basically it's in standby mode now, just waiting for the door to open. That's a lot better than 50 milliamps. 50 milliamps compared to half a milliamp. Take that every day long, all day long I should say. We'll see if we can open the door again. Hold on, get the latch. Right, sorry, I'm doing this sort of one-handed. Open the door. Circuit fires in, power to the control board for the step. Multimeter is overloading because, as I say, this board is drawing about 40-50 milliamps because the relay is triggered on it. We look down here, steps out, close the door, steps close in a few seconds because we're on a timer, remember. You'll lose all the power to the step. 3, 2, 1. Power's off, relay's gone open circuit, draw to the board, it'll drop down half a milliamp. So yeah, that all works, that's fine. What I'll need to do now is wire it in permanently. I'll probably, like I said last time, put that little board in a bit of heat shrink and tuck it away. Had I thought about it all in one go, I'd have probably designed a PCB to go into that box that incorporated this timer. That might be another video, we'll see what time I got. But yeah, that's certainly took 50 milliamps down to half a milliamp, and that's what I'm looking for. So the poor old battery in here is not going to be subjected to undue stress when it's not actually doing anything. But there you go, I hope you found it interesting, and thanks for watching.